Hey, CJ Math students, and welcome to Math Test 222, Compound Probability. So today we're going to have multiple events happening at once. That's what compound means. So if two or more events are put together to make one event, you're usually going to have a word or, and that means that you're going to go ahead and add those probabilities together. So like, what's the probability of me rolling a 1 or a 2? Well, that's 2 out of 6, right? Let's do some examples. There are 7 red, 8 green, 6 blue marbles. Kate's going to select one marble at random. What's the probability she will select green or blue? So the probability of green is 8 out of, we got to add these up and say, okay, that's 15 plus 6, 21. So 8 out of 21 plus the blue marbles, which is 6 out of 21. So the probability is 14 out of 21. Or if you want to simplify it down to 2/3, divide both of those by 7, right? A card is randomly selected from a deck of 52. What is the probability the card is a 10 or a face card? Well, there are 4 10s, a heart, a diamond, a spade, a club. And there are face cards. There are going to be Jack, Queen, King, and then you can have heart, diamond, club, or spade of those Jack, King. So it's 4 out of 52 plus 12 out of 52, which equals 16 out of 52. You're going to do number 3 in Edpuzzle. Probability you roll a 1 or an even number. The dice is obviously numbered 1 through 6. Okay. You're going to 4 6 or 2/3. Now, sometimes you're going to see the word and because of your finding probability of more than one event, right? When you have that word and, you are multiplying. Now, there are a couple scenarios that happen. Sometimes you have events where you will replace what you picked. So like if I'm pulling a bag of marbles with different colors and I pull out a red one and then I put it back in the bag, that is with replacement. But if I'm pulling a bag of marbles and I pull out a red one and I do it without replacement, then the denominator needs to decrease because I have one less thing in my bag for probability. Let's do a couple examples if that was confusing to you. All right. So out of 20 students, your teacher chooses students at random to present their project. What is the probability that she chooses you first? So there's only one you in the class, right? So 1 out of 20. And then chooses Kim second. Well, she's not going to, once she's chosen you, there's one less person to choose. There's only one Kim in the class. So 1 out of 19, right? This was without replacement. When she chose you, you were no longer in that pile of students to choose from. When you multiply fractions, you multiply literally straight across, and you get 1 over 380. Very small probability. Okay. Flip a fair coin. What's the probability you show heads on the first flip and then tails on the second flip? Well, heads on the first flip is 1 out of 2 possibilities. And then notice, like, it's not like we're removing a side of the coin. That still is there. So we have with replacement here. It's not like all of a sudden our total outcomes have somehow changed, right? So heads on the first one is 1/2, tails on the second one is 1/2. 1/2 times 1/2 is equal to 1/4 as your answer. Let's do one more. Tom has 4 navy socks, 6 black socks in a drawer. One dark morning, he randomly pulls 2 socks so he can't see the color. What's the probability he will select a pair of navy socks? So his first pull, we're looking at navy socks, and if there are 10 socks total, first pull is 4 out of 10. So let's say he picked a navy sock. That means the next pull, pay attention here, we no longer have 10 socks because we're keeping that navy sock, is out of 9. And if I pulled one of the 4 navy socks, that's 3 navy socks left. So I have 12 over 90, which if you put in your calculator, it will simplify to 2/15. I know that might have been confusing. Rewatch if you need to. Number 4, there are 2 glasses of root beer, 4 glasses of cola on the counter. They look the same. They don't have any labels, right? Dave drinks 2 of them at random. What is the probability he drank 2 glasses of cola? So glass of cola, there are 4 out of them, and there are 6 total because 2 plus 4 is 6. So the first probability is 4/6, right? He's going to drink that cola. He's going to put that away. So we no longer have 6. We have 5 left. And because he drank a cola, there are only 3 possible options left. So it gets you 12 out of 30, which again, if you simplify, you get 2/5, 40% option. Going on the back, a green die and a red die are tossed. What's the probability? 4 shows on green, 5 shows on red. Notice there's no like, oh, once I rolled a 4, it's no longer existing, right? There's a replacement here. So probability of getting a 4 is a 1 out of 6, because remember, dice are always numbered 1 through 6, right? The probability of getting a red, or a 5 on a red, is again 1 through 6. So the probability total, just multiply them together, gives you 1 over 36, right? This one, you're playing this game where you want to spin and get more than 500 on your first spin, and then go bankrupt on your second spin. So all the A's are ones that are more than 500. So we got 1, 2, 3, 4, 5, 6, 7, 8. 8 possible ways to get more than 500. I'll give you a hint. There are 24 spaces, so 8 out of 24. And then once you spin, it's not like they're going to pull that up and you can no longer land on that space. So this is with replacement, so there are still 24. And then going bankrupt, there are only 2 bankrupt spots, here, and there are still 24 spaces. So the probability of getting something higher than 500 and then going bankrupt is going to give you 16 over 576, which if you simplify that, that's 1 over 36. If you put it in the calculator, it'll probably just give you 1 over 36 right off the bat. All right, number 9. If you haven't understood today's lesson, here's where number 9 comes into play, where hopefully you can pick up on the patterns. So a box contains 5 red and 7 green marbles. So basically 12 marbles altogether. Find the probability of drawing 2 red marbles. So with replacement, meaning I'm going to take out a marble and then I'm going to put it back in. So with replacement, red marble is just 5 out of 12. And since I replaced it, it's still 5 out of 12. So that gets you 25 over 144. Now, without replacement means I'm going to take out that red marble, and then that means I have less marbles in that box. I'm not going to put it back. So it's still 5 out of 12, but then the next drawing is out of 11, and there are only 4 red marbles left. So that gets us 20 over 132. If you simplify that, that gets you 5 over 33. Okay, so try number 10 in Edpuzzle here. What's the probability of drawing a red, then a blue, then a white? And you're replacing, so your denominator is not going to change since you're going to replace. And then let's try number 11A in Edpuzzle without replacement. So meaning your amount of nickels and coins that you have is actually going to change. And then 11B in Edpuzzle, a nickel and a dime with replacement, meaning your denominator is not going to